Hello everyone, welcome to my next tutorial. It is a part 7 of solar cell application tutorial. In this tutorial, we are going to discuss about intensity modulated photocurrent spectroscopy of a bulk heterojunction solar cell. So firstly, we will be see IV curve, then solar cell intensity modulated photocurrent spectroscopy. How we can calculate in the Setfos. So before start of the tutorial, I want to introduce myself. I am Sahil Verma, application engineer of the well-known company Impulse Technology. About the company, features and their services we have already discussed in our previous video. So who has not seen it my previous video, please check out the playlist. In the playlist video you can see how we can use Setfos software and their GUI and about the company and their partnerships. Firstly, I will be show one of the PPT. You can see we are going to simulate intensity modulated photocurrent spectroscopy of a bulk heterojunction solar cells. Firstly, I will show how we can calculate IV curve like the IV curve of a current voltage graph. It is a chart used to compare the performance of different solar technology. It can be used to analyze how components in photovoltaic cell work together and measure the efficiency at which power is generated from sunlight energy. Second tutorial, this part solar cell intensity modulated photocurrent spectroscopy, the technique used to characterize the dynamic behavior of charge carrier and ions with the device, providing insight into electron lifetime, recombinations, dynamics, and charge transport. How we can fill these data and how we can calculate these parameters in the Setfos, I will show in the Setfos GUI. So now I'm going to start tutorial. You can see how we can provide input one by one, how we can find these properties. Always click at the Setfos right side and run as an administrator. About the Setfos and their GUI, how we can put inputs, we have already provided in our previous video, so you can get a lot of the information about Setfos. In here, we will be show one of the tutorials parts IV curve and intensity modulated photospectroscopy characteristics. So these are the new features that introduced in the Setfos. So you can see at the top side and that new things that come you can see. If you want to update your Setfos, so you can click at here. Their GUI we have already discussed. So if you want to create your new simulations files, simply click at here and one of the example files is also given at here. You can see solar cell intensity modulated photoscopy, solar cell internal quantum efficiency. Like this, Setfos also give the ability about the examples and you can see their data, but for your better understandings I will show how we can create new files and how we can find these properties. For the create new simulation file, you can click at here. For the existing examples, you can click at here. If you want to save your current files like this, so you can see at here the existing results are present. It is a passive optic modules. These are the four modules of the Setfos, one of the absorption modules, depth diffusion modules, and emission modules and scattering modules. These are the modes are also present: master equation modes, shift modes, optimization modes, and fit emission zone parameter. For large view, you can click at here. Now you can see I'm going to create at here layer structures. Here I'm considering at here the simple examples of the solar cells. So you can see how we can find IV curve, glass. One by one you can create at here layer structures and you can provide at here name of your layer. It totally depend on you which type of layer you want to consider at here and which type of thickness you want to give in here. So all the input totally depend on you. P dot P3 HT PCBM. You can add one more layer and give at here aluminum. We have already created that type of layer structures in our previous video, but I will show how we can find in here IV curve surrounding. Now you can provide at here the thickness value. It will be same. For the glass you can consider at here 10 nm. For the ITO you can choose at here 120 nm. For the P dot it can be 110 and in here you can choose 100 at the below sides. You can also choose 100. Surrounding you can choose at here 0 mm. Top and bottom layer are semi-infinite medium, so thickness are irrelevant at here. So layer structures are completed. You can see at here according to the thickness layer structure are created. Click at here. So you can click at here for the large view. Which layers is wavelength dependent, so you need to import refractive index that supported .nk files. For the glass it is incoherent ITO. You need to import at here refractive index files. So simply click at here. You can see .nk files and you can import at here your file. It supported .nk files. You can see at here number of the examples and .nk files are given. So you can see like this. Simply you can import at here .nk files like this, and you can see at here graph. If you want to edit your data, you can simply edit and give at here new data, and you can save your files. So you can create at here own files, and if you want to save in this type of files, so you can provide at here new names and like this ITO, and you can save. So it totally depend on you. Similarly you can import at here pedot that supported pedot.nk files. You can simply click at top and like this P3HT similarly you can import, and similarly for the aluminum. Generally, IV curve based on the device similar. We now perform a full simulation to calculate IV characteristics of device built in the potential. So we need to set at here drift diffusion modules for the electrical parameters, and you need to activate absorption settings so you can calculate all of the absorption parameters, and for the drift diffusion you can calculate all the electrical parameters. So you can see at here shift, single wavelength and energy. So that parameter you want to see, you can consider it here steps 5. It can be same. If you want to change at here any parameter, you can change. You can move toward the below sides. You can see at here 550 nms, so you can choose at here default value 460 nms. I'm considering here only example parameters. If you want to change that parameter according to your choice, so it totally depends on you. You can change these values. Now we need to activate drift diffusion settings. You can see steady state, transient, AC impedance, intensity modulated photocurrent spectroscopy, and intensity modulated voltage spectroscopy. So that type of parameter you want to choose, you can easily choose. And firstly we need to import that here electrical material files, and so you need to enable that general tab for the electrode. Similarly for the aluminum electrode, and in between the electrode you need to enable semiconducting layers. Now you can provide at here the electrode value for the pedot. You can see ohmic, thermionic, organic, thermionic, inorganic. So you can choose at here the thermionic organics, and boundary condition work functions 4.5. You can choose at here 5 electron volt. If you want to give internal quantum efficiency and open circuit voltage or fill factors, optical band gap, you can provide at here. For the aluminum you can set at here same thermionic organics, and these value you can set 4.309. In here I am providing only examples value that given in the tutorials. Now we need to import at here the semiconducting files. In the semiconducting that supported .em file formats, you can see a lot of the material files are given. So you need to import at here p3htpcbm.em file format. So you can search at here p3htpcbm. You can see already these value are fulfilled in here excitant. If you want to add more excitant, you can add. You can see these value are autofill. If you want to give at here your own value, you can provide. Mobile ions and recombinations. Number of the recombination model are given, so you can choose at here Langevin, and recombination efficiency consider at here 1. You can set at here the voltage 0, temperature it will be same 290 K. At the bottom side you can create at here the own electrical circuit that we have already told in the previous video. So all of the absorption settings and drift diffusion settings are completed. and layer structures are already completed. So now we set these shift mode parameters, that value you want to shift. So we are going to select at here the voltage, and that ranges you want to shift, so you can select 0 to 1, and step we are going to consider at here 0.025, and it is a voltage. So you can see all the input parameter we have already filled. So you can provide at here your new name, solar cell vi curve. You select at here the p3st pcbm, and in here you can see exciter parameters are already given. So in the drift vision setting you need to enable that excitant tag. Now you can simply click at here the play button. You can see open circuit voltage, short circuit currents, fill factor, maximum power density, built-in voltage, current balance, device currents, excitant density, excitant rates, excitant rate P3ST PCBM, power conversion efficiency, and power density. You can see at here the voltage and current graph for device currents and band diagram. You can check charge density, charge and resistance, currents. You can check electrical fields, excitant density, excitant rate. If you want to move like this, you can simply click at here the play button. Recombinations for the Langevin, you can see absolute residual error, iteration residual error. You can see at here the photocurrents, state contributions. You can check at here the passive optic properties one by one. Transmitted color, you can see absorption for the S polarization and for the P polarizations. Layer absorption, you can also see reflectance, state contributions, and transmittance. Wavelength and voltage types are also given. Now I am going to discuss about solar cell intensity modulated photocurrent spectroscopy, that mainly used for the studying dye sensitized solar cells in order to probe the transport time of charge carrier in the device. We have simulated in here the intensity modulated photocurrent spectroscopy response of organic solar cells, that IV characteristics generally based on the polymer. So now I am going to create at here the new simulations file. You can click at here the plus I symbols and provide at here new layer name one by one. Surrounding, subtract, ITO, dot, polymer. You can add one more layer at here, aluminum, surrounding air. Now you need to provide at here the thickness. It can be 0. For the subtract you can choose at here the 100 nm, and for the ITO you can consider at here the 75 nm. For the pedot you can choose 60 nm. Polymer you can select at here 90. For the aluminum it will be same 100, and it can be 1. You can consider at here the 1 value, and for the subtract you can consider at here 1.5. Which layer is wavelength dependent, so you need to import at here the refractive index .nk files, and as like ITO, as we have already told, it here supported .nk files, so simply choose ITO.nk files. Pedot and polymers. For the polymer you need to import GSID 1406 C70 files. If you don't have that type of file, so you can simply edit that data, and you can also import your files from the example file where presents polymer. And aluminum you need to select al.nk. Surrounding it will be same. You need to activate that absorption settings, and you can provide at here the wavelength and their ranges like this at the top side. You can consider at here the step 10. In the illumination spectrum files you can choose white spectrums, and location and times it totally depend on you. Setfos also give the ability At the fixed times, you can calculate the absorption parameters. Firstly, we need to import that here the blue LED 01 spectrum files like this, and data column you can choose at here the 2. I am considering only at here examples parameters. If you want to change, you can change. And the intensity scaling value you can provide 0.52. We need to activate drift diffusion modules because I am going to calculate at here the intensity modulated photocurrent spectroscopy. So you need to select that mode. You can check steady state solver are also given. The solver methods are given auto, Newton, Gamal, and in the residuum you can see auto current continuity, relativity change, number of the iteration, absolute current continuity. You can select at here the number of iterations 1. You can see at here the amplitude 0.001. You can provide at here only single value, but if you want to shift, you can shift these value, and which type of ranges you want to shift you can select. If you want to shift at here the list, you can select that random log, element log like this. I am considering only at here log, and from 100 to 1 point you can select from 100 to that value, and step you can consider 10. Unit you can choose. At the bottom side you can see status semiconducting layer are not defined. So if you calculated electrical parameters, so you need to activate that general tab for electrode and also for aluminum, and in between the electrode you need to activate that semiconducting layer. For the pedot, you need to select ohmic, and value you can consider at here the 5 electron volt. Similarly, for the aluminum, you can choose 4.019 electron volt. And you need to import that semiconducting file. You can see at here number of the examples files are given. So you can simply import at here that econ.em files, because in here the supported .em file formats. Simply select that tab. If you have done that file, so you can also export from the examples from this tab. In the drift vision settings, if you want to change that voltage parameter, you can change. If you want to change that temperature, you can also change that value. Now you can see layer structures are completed, absorption settings are completed, drift diffusion settings are completed, and output settings are also completed. And here no excitant traps, and you can see only recombinations models are given. You need to provide at here your file name, intensity modulated photocurrent spectroscopy solar cell, and simply click at here the play button. Now you can check in here your results, electrical key figures and optical key figures. Built-in voltage, reflected color are also given. AC internal quantum efficiency. One by one you can check electrical impedance parameters like this. Electrical impedance profiles, N phase, P phase. If you want to shift that value, so you can click at here the play button. You can see at here the some variations. One by one you can check all of the value. Band diagram, charge density, charge generations, currents, electrical field, mobility, potential, and optical profiles like this. Absorption parameters, layer absorptions, reflectance, state contributions, and transmittance. You can check your parameter from the script modes. If you have done any mistakes, or so you can edit in here and simply click at here the play button. So I hope you understand my tutorials and you got my points, what we are actually doing in here and how we can simulate IV curve, solar cell intensity modulated photocurrent spectroscopy, and polymers IV curves. So now I'm going to end my tutorials. If you have any query related to this, you can ask in the comment box, and my email are also given in the description box and end of the video. So you can visit our website's Impulse Technology also, and who has not seen it my previous video, please check out the playlist. Thank you very much.